So in this section we're going to be looking at lasers, an introduction to what a laser is, and 4 main properties of lasers. So let's begin by looking at the abbreviation laser. LASER stands for light amplification by stimulated emission of radiation. So there are two main phenomenon which encompass a laser. One is amplification and the other is simulated emission. Simulated emission is what gives rise to the photons or the light particles which constitute a laser, and amplification is responsible for some of the other properties of a laser. For example, for its intensity, its directionality and so on, they are because of amplification. So the two main phenomena that are involved in the production of laser light are simulated emission and amplification. So we will be looking at simulated emission in a future class where we study in detail about how these photons or light particles are actually generated, but for now we will take a quick look at what exactly this amplification is. So to formally define a laser, it is a device that generates highly intense, monochromatic, coherent and directional beam of electromagnetic radiation through the process of repeated amplification of simulated emission. So what does this definition tell us? Laser is a device which generates electromagnetic radiation, and this electromagnetic radiation has 4 properties: highly intense, monochromatic, coherent and directional. And how is this radiation generated? There is something called stimulated emission which happens first, and then whatever is emitted through this stimulated emission is amplified repeatedly to give rise to these electromagnetic waves. So that is the basic definition of a laser. And another term which can be used interchangeably with the word device is oscillator. And why can a laser also be called an oscillator? Oscillator is something that builds up a strong signal from an initially weak signal by repeated amplification, and that is what a laser does, right? Your simulated emission is responsible for generating photons or electromagnetic particles. It only gives rise to these particles. What makes these particles or waves stronger, what amplifies them, is the laser through repeated amplification. So a laser in other terms can also be called an oscillator. So we will now look at this repeated amplification in a little more detail. Yeah, so this diagram is a demonstration of the setup of a laser. So we have 2 highly polished surfaces which can be approximated as plane mirrors. Let's call them M1 and M2. They are placed parallel to each other, separated by a certain distance. So at this region we have some mechanism, some setup which produces photons through simulated emission. So what exactly is the procedure that causes this simulated emission to take place? How these photons are born? We will study that in detail in a future lecture. So for now, just assume there is something there which gives rise to photons. So these photons hit the surface of the mirror at random angles. So I have drawn the arrows only on one direction, implying that they hit the mirror M2. But of course the photons will also hit the mirror M1. They will be incident in all directions, actually, over here, 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 in all directions. Some of them will hit the surface of either of the mirrors at any angle. Some of them, which are incident in such a haphazard manner, will not hit the mirror, so they go out of the setup and those photons are lost. So there is some loss of energy also. But for now, what we need to understand is we have 2 mirrors placed parallel to each other, separated by a distance. In between them we have some mechanism that produces photons through a process called simulated emission. These photons are incident on the mirror and throughout the setup at different angles. So those which are not incident on the mirror are usually lost. We will consider the photons which are incident on the mirrors, on either of the mirrors at any angle. The photons get reflected, they turn back and they hit the other mirror. Again from there they get reflected, they turn back, they hit M2, M1 and so on. So this repeated back and forth, hitting a mirror, getting reflected, hitting a mirror, getting reflected, it does 2 things. One, it ensures that the photon does not go out of the setup and gets lost like these ones. So this one which hit the mirror, after hitting the mirror, the mirror ensures that it is reflected at an appropriate angle such that it will hit M1 again, then M2, then M1. So the photon remains within the setup and helps in the production of light, unlike these photons which went out of the setup and were lost. That is one thing. The second thing is, these photons initially they are incident at different angles. So if you look at each photon, let's say as a wave, because light has both wave nature as well as particle nature as we've studied. So each wave has a different phase. That is what we mean when we say each of them is incident at a different angle, right? So when they get reflected from the mirror, they all start following the same horizontal path, which is denoted by these yellow and orange lines. So the phase difference between everything is adjusted and brought to the minimum, meaning the waves superimpose. So the final light produced has maximum intensity. That is one thing. So this is what I meant when I said repeated amplification is responsible for some of the properties of a laser, such as high intensity. So, and the only reason I put these lines in orange is just so that the diagram doesn't become too cluttered and you're able to appreciate the direction in which it moves. There is nothing special about the movement from M1 to M2 as compared to the opposite. So the idea is you have two mirrors, you have a setup here, the photons are incident on either of the mirrors at any angle. Some photons are incident not on the mirror, but they just go out of the setup and they get lost. But whatever is incident on the mirror reflects them back at an appropriate angle such that, number one, they stay within the setup, they keep reflecting back and forth between M1 and M2. Hence, the photons remain within the setup and remain contributing to light emission. Number two, the photons, when they were initially incident, there was a large phase difference between them because each photon was incident at a different angle on the mirror. Now, because of reflection, all of them are fine-tuned to more or less the same path or the same or parallel lines, so to speak. So the phase difference is minimized, so the intensity of the final light is maximum. So this is what is repeated amplification. This repeated back and forth reflection is what we call repeated amplification. So this is one of the two basic phenomena which encompass a laser.